So in this question, we are given a 3D harmonic oscillator, right? For harmonic oscillator, I'm using HO. Fine, and its potential is given that V of R is equal to 1 over 2 m omega square R square, right? Now, the first part is that we need to convert this one 3D harmonic oscillator into three, let's write it as three 1D harmonic oscillators, right? The small is for oscillators. Fine. So we are required to convert one 3D harmonic oscillator into three 1D harmonic oscillators using the separation of variables technique, right? So the solution is very simple, but before starting with the solution, you must know one thing, that the energy eigenvalue energy eigenvalue of the quantum harmonic oscillator is given by the equation E is equal to n plus 1 divided by 2 times the Planck's constants times the omega, right? That is the angular velocity, right? Now, okay, so from here we are going to start our equation, right? Now, the given potential of the system is V of R is equal to 1 divided by 2 m times omega square times r square, right? Now, since it's a Cartesian coordinate system, right, so this r square is equal to x square plus y square plus z square. So I'm going to use it, and we would write that v is equal to 1 over 2 m omega square x square plus y square plus z square, right? Let's say that this is equation 1. Now, the next thing is that, as we know that we have the um, equation negative Planck square divided by 2m del square psi plus v times psi is equal to e times psi, right? So now, as the time independent wave function, time independent wave function is this equation, that is excuse me, a square divided by 2 into partially into derivative of psi, double derivative of psi with respect to x, plus double derivative of psi with respect to y, plus double derivative of psi with respect to z, plus v times psi is equal to e times psi, right? So over here, as you can see, that this wave function, right, it satisfies this wave function, right? It satisfies this equation. Fine. And since this x, y, and z, they do not depend on each other, right? So it means that we can safely separate it. So this would become psi xyz is equal to x of small x, y of small y, z of small z, right? So the next step is to rewrite this equation according to this equation, right? So we would have an equation that looks something like this. So a square divided by 2 yz. Why we are not writing yz x over here is because we are taking the derivative with respect to x. Okay. So next, as we are taking the derivative with respect to y, so over here we would have xz, and over here we would have d square y plus, again as we are taking the derivative with respect to z, so we would have xy over here, and over here we would have d square z, right? Plus v times psi is equal to e times psi, it remains the same. Now from equation 1, from this equation, okay, we are going to substitute it over here, right? So our equation would become something like this. Fine. So negative l square divided by 2m m, right? Sorry, I forgot to write m over here. So 1 divided by x d square x divided by dx square plus 1 divided by y d square y divided by dy square plus 1 divided by z d square z divided by dz square, plus plugging the value of v. So I have 1 over 2 m times omega square x square plus y square plus z square is equal to e, right? So the next step is to write this equation separately, means to write this equation um, with separate terms for each variable x, y, and z, right? One equation containing all the variables but within separate terms. Fine. So then this equation would become negative a square divided by 2m into 1 divided by x d square x divided by dx square plus 1 divided by 2 m omega square x square, right? So as you can see that this is a one term containing all the things containing the variable x, right? So as it is a very long term, so I'm going to write the next term in the next line. So over here I have negative s square divided by 2m into 1 divided by y d square y divided by dy square plus 1 divided by 2m times omega square y square, right? Similarly we will write the next term for z. So into 1 divided by z d square z divided by d z square plus 1 divided by 2 m omega square z square, right? So this would be equal to e. The right hand side remains the same, there is no change over here. Now as you can see that we have written each term separately containing only one variable. This term contains x, this term contains y, and this term contains z. So it means that we can equate each terms to its corresponding value of e, right? So it means that we can write it as negative h square divided by 2m times 1 over x d square x divided by dx square plus 1 divided by 2 m omega square x square is equal to ex, right? Over here what we have done, we have just separated the variables completely, right? Similarly we would write another value for y, another equation for y, right? So x square divided by 2m 1 divided by y d square y divided by dy square plus 1 divided by 2 m times omega square times y square is equal to ey, right? E sub y. And the last one would be for z. So a square divided by 2m 1 divided by z times d square z divided by t square z plus 1 divided by 2 m times omega times z square is equal to E sub z, right? And over here we have that E is equal to Ex plus Ey plus Ez, right? So now the next thing is to use the equation, write the excuse me, the energy eigenvalue, right? So we are going to use it to find out the equation for Ex, Ey, and Ez, right? So let's find it out, right? Now the equation for Ex would be nx plus 1 divided by 2 Planck's constant sine omega. Ey would be n sub y plus 1 divided by 2 Planck's constant time omega, and Ez would be n sub z plus 1 divided by 2 Planck constant time omega, right? And as you can see over here, we have E is equal to the sum of Ex, Ey, and Ez, right? So we are going to plug in these values of Ex, Ey, and Ez over here, okay? So that I have an equation for the total energy. So that would be n plus 3 by 2 a time omega, right? And for all n elements, z positive, right? And this n is equal to the sum of all n's, right? So nx, my mistake, sorry, nx, ny plus and z, right? So this is the energy for total energy, right, for the system. And this is solution for your part A, right, that asks us to convert this one 3D harmonic oscillator into three 1D harmonic oscillators, right? So this is a solution for that. Now the next step, the next part, sorry, is to find out the degeneracy, uh, degeneracy for the system, right? Um, Now, what we are going to do over here is that we are going to write nx is equal to n, right? So this implies that ny is equal to 0, and nz would also be equal to 0, right? Because as n is the sum of all of these x, y, and z components, right? And if nx is equal to n, so it means that ny and n sub z is equal to 0, right? So in this case, the degeneracy would mean that d is equal to 1, right? Or we would have an equation that not an equation, a condition, right? So in this, what we are going to do is that we are going to let that nx is equal to n minus 1. So it means that ny is equal to 1 and n sub z is equal to 0. So consider this case, or consider another case where we are letting nx is equal to n minus 2. So in this case, ny is equal to 2 and nz is still is equal to 0, right? Or what we are going to consider is that ny is equal to 0 and n sub z is equal to 2, right? Or what we could consider over here is that ny is equal to 1 and nz is also equal to 1. Now these are the possible values of ny and nz when we are considering this case that nx is equal to n minus 2. right? So then again we will let that um, d is equal to 3 and so on, right? So because it would go on and on, right? So the degeneracy for this would be d of n is equal to sigma or summation n plus 1 I is equal to 1, I is equal to n plus 1 n plus 2 divided by 2, right? So this is your value or your solution for part B, right? It was very easy. So this is